All right, so for this example, we have a wave that has a period of 10 seconds. It's in 5 feet of water, and it asks us to find the wavelength, single wave celerity, and group celerity for the wave. Right, so following the same process as before, the deep water wavelength is equal to g times t squared over 2 pi. So hopefully everyone recognizes this is exactly the same deep water wavelength that we've been doing. And we can see that if you plug in all the values, you still get 512.5 feet. Right, so then after that, we do our depth divided by deep water wavelength so that we can classify our wave. So 5 feet divided by 512.5 feet gives us a ratio of 0.0098. And if we look at that, 0.0098 is less than 0.05. Therefore, we have a shallow water wave, or shallow wave. All right, so then if we look at our table, we can see that for a shallow wave, the wavelength is equal to t times the square root of acceleration due to gravity times water depth. So 10 seconds times the square root of 32.2 feet per second squared times 5 feet. Plug that all into our calculator and we get a wavelength of 127 feet. All right, so moving on to the next thing we want to calculate, the single wave celerity is equal to the square root of gravity times depth. So that's the square root of 32.2 feet per second squared times 5 feet. Plug it all in and we get 12.7 feet per second. Now you may notice that square root of g times d, we kind of already did that. An equivalent expression is wavelength divided by period, right? Because previously we did t times square root of gd. Now we just want gd, so we can just take what we did before, divide by the period. All right, so not too bad. And then lastly, for group celerity, we see that for shallow water waves, the group celerity is equal to the single wave celerity. And since we've already solved for it, easy enough, 12.7 feet per second. Now, over all three of these examples, hopefully you can recognize some of the concepts that we've been talking about as conceptually, and you can see that they're represented in the math, right? The deep water wavelength of the wave is always the same. It's always 512.5 feet. However, you could see as the actual wavelength L started off at 512 feet when we were in deep water, and then as we moved into a transitional period, it went down to 378 feet, and then as we got all the way into shallower water, it dropped off all the way down to 127 feet, right? And then you can also see as the single wave celerity and group celerity started off far apart, but as we got shallower and shallower and shallower, they got closer together. Right.